In this video, we will learn about the heap sort algorithm and how to implement it using C++ code. A heap is a tree data structure. There are different types of heaps, like min heaps, which have the least element as the root, and max heaps, which have the maximum element as the root. The first step is to create a heap out of the elements in the collection. For example, we can create a min heap which has the lowest element in the collection as the root. Once we get an element to the top, we remove it and then recreate the min heap. At the end, we are left with a sorted collection. Now that we understand the concept of a heap sort, let's learn how to implement it using C++ code. After that, let's create a function with a void return type named heapify that takes in three parameters: a vector of ints named list, an int named size, and an int named I. Inside of this function, we will create an int variable named largest that we set equal to I. Next, we will have an int variable named leftchild that we set equal to 2 times I plus 1. This is the formula that you could use on a heap, represented as a list or array, to retrieve a node's left child. Then we will have a variable of type int, named rightchild, that we set equal to 2 times I plus 2. If leftchild is less than size, and list at index leftchild is greater than list at index largest, we will set largest equal to leftchild. Next will come another if statement that checks if rightchild is less than size, and list at index rightchild is greater than list at index largest. If so, we will set largest equal to rightchild. If largest does not equal I, we will swap list at index I with list at index largest by creating an int variable named temp that we set equal to list at index I. Then we will set list at index I equal to list at index largest. After that, we will set list at index largest equal to temp, and then we will make a recursive call to our heapify function and pass in list as the first argument, size as the second argument, and largest as the third argument. Then we will create a function that returns an integer named heapsort that takes in two parameters, a vector of integers named list, and an integer named size. Inside of this function, we will have a for loop that starts at int I equals size divided by 2 minus 1, runs while I is greater than or equal to 0, and decrements I by 1 each time. Inside of this for loop, we will make a call to the heapify function and pass in list as the first argument, size as the second argument, and I as the third argument. After that, we will have a second for loop that begins at int I equals size minus 1, runs while I is greater than 0, and decrements I by 1 each iteration. Inside of this for loop, we will swap the elements at list index I and list index 0. First, we will create an int variable named temp that we set equal to list at index I. Then we will set list at index I equal to list at index 0. After that, we will set list at index 0 equal to temp. And finally, we will make a call to the heapify function and pass in list as the first argument, I as the second argument, and 0 as the third argument. Inside of C++'s main function, we will make a call to the heap sort function and pass in numbers as the first argument, and 5 as the second argument. On line 10 there is a typo. It should be an if statement and not the int keyword. When we run the code, notice that the elements in the list were sorted thanks to the heap sort algorithm that we implemented. In this video, we will learn about the shell sort algorithm and how to implement it using C++. A shell sort is an improvement on the insertion sort. It allows for the exchange of items that are far away. Let's look at a conceptual example using the collection of integers 20, 10, 50, 2, and 5. The gap will start off at the length of the list divided by 2. 5 divided by 2 is 2 with a remainder. So for the first pass of this algorithm, we consider elements separated by a gap of 2. First, we compare 20, which is at index 0, and 50, which is at index 2. 20 is less than 50, and is to the left of it, so we don't swap these elements. Next, we compare the elements 10 and 2. Since 2 is less than 10, we swap these elements. Next up are 50 and 5. These elements are out of order, so we swap them. Now that we have went through the entire list, checking with a gap of 2, we divide the gap by 2, and the gap now becomes 1. First, the elements 20 and 2 are compared. These are out of order, so they get swapped. Next, we compare 20 and 5. Since 5 is less than 20, these get swapped. After that, the elements 20 and 10 get compared. 20 is less than 10, so we swap these. The elements in the collection are now in order. Now that we have a conceptual understanding of the shell sort algorithm, let's learn how to implement it using C++ code. Let's create a function with a void return type named shell sort that takes in two parameters, a vector of ints named list and an int named size. Inside of this function we will have a for loop that starts at int gap equals size divided by 2, runs while gap is greater than 0, and divides gap in half each time. Then we will have a nested for loop that starts at int I equals gap, runs while I is less than size, and increments I by 1 each time. Inside of this for loop, let's create an int variable named temp that we assign an initial value of list at index I. Then we will create an int variable j. For j equals I, while j is greater than or equal to gap, and the list at index j minus gap is greater than temp, decrementing j by gap each iteration, we will set list at index j equal to list at index j minus gap. Then, outside of this for loop but still inside of the other two, we will set list at index j equal to temp. Time to go inside of C++'s main function and make a call to shell sort. We will pass in numbers as the first argument and 5 as the second argument. When we run the code, notice that the elements are now in order thanks to the shell sort algorithm that we implemented.